Let's do a partial victory lap on what we've learned with nonlinear optimization and Excel solver options. So let's bring up solver here. We've been using GRG nonlinear for optimization for nonlinear functions. We haven't really said what GRG stands for. It stands for Generalized Reduced Gradient. And the generalized reduced is about constrained problems. We'll talk about that in future modules, but at least we understand the gradient part now. If we look at the options here, in the general options, where'd it go? There we go. For all methods, it has a checkbox called Use Automatic Scaling. We've said there it's trying to kind of adjust the diagonal, or use a kind of approximate Hessian that's just the diagonal to make the variable scaled better, to kind of reduce how eccentric the ellipsoid contours of the objective function are. And then under the GRG nonlinear options, there's this option to use either forward derivatives or central derivatives, and we've talked about that as well when we talked about how to estimate gradients and stuff. What haven't we talked about that we can look forward to in the future? Let's see. Way back earlier in the semester, we talked about integer constraints. We haven't said how we solve integer problems, so we haven't exactly talked about this integer optimality. It's pretty straightforward. You can tell solver, don't spend more than this amount of time on a problem or this number of iterations. We haven't talked about evolutionary solver at all. Well, that'll be its own module later. And under GRG nonlinear, we haven't talked about multi-start. Multi-start is something you can do for nonlinear problems if you're worried about getting stuck in a local optimum that's not global. You can basically say, start in 100 different randomly located places, run GRG nonlinear for all of them, and then report the best one. Or you can change this to 1,000 if you want. Of course, the higher you make it, the longer it's going to take. Let's see, so I read somewhere that it doesn't just report the best one, it does some kind of clustering afterward, and I don't understand why. So if you're interested, you could make that a project topic. Evolutionary also helps us avoid getting stuck in non-global mins or maxes, and it also takes longer than GRG nonlinear. And so the big question is, how do we know when to be worried about getting stuck in a local min or max that's not global? And I'm glad you asked, and we're going to talk about that in our next module.